Assalamualaikum and very good day to all panels and audience. It is an honor for me today stand in front of you to deliver a presentation. I would like to present about the course MEC 602 Final Year Project 2. Before that, let me introduce about myself first. My name is Shamsul Ridzuan Mohamad Kasim. I am Bachelor of Mechanical Engineering student from University Technology Mara UiTM, and my final year project named Development of a Bio-Hybrid Electrical Powertrain for Mountain Bike MTB. I have been supervised by Associate Professor TS Dr. Ramzyzan Ramly, and hopefully this presentation will give you guys the overview of the project very well. First of all, this presentation is cover about 5 main chapters, starting with project summary, introduction, literature review, methodology, result and discussion, and lastly conclusion. Project summary. The concept of a biohybrid electrical powertrain system is that it combines human power pedaling with an electrical motor that runs at the same times. This electric motor was powered by a 24-volt AC charger which creates electricity when the user began pedaling, and the electricity was stored in the battery. This project shows how to design and develop an electric powertrain for a mountain bike, also known as an MTB. The purpose is to analyze the input from crankshaft to produce output, which is voltage generated by generator. A test bench has been developed to achieve the purpose of this project. The pedaling force will be able to create a good amount of input rotation force to the charger and produce a current to charge the battery for long-term use, according to the finding of the study. Finally, because it mobilizes the MTB using both electric and human force, this type of MTB can promote a healthy lifestyle and reduce human power when riding MTB. Introduction. Recently, the necessity to reduce air pollution together with the aging of the population has led the research in the mobility field. In particular, biohybrid mountain bike refers to mountain bike which is a human electric hybrid bicycle that supports the rider with electric power. In Europe, it is also called pedelec. The pedelec has a driving torque that comes from both the electric motor and the rider. As the result, this vehicle offers the benefit of improving the mobility capability of normal bicycle through electrical assistance, as well as being environmentally friendly as zero-emission vehicle. This project also presents properties of an electrical powertrain designed for a mountain bike, design consideration of powertrain as well as inverter, electric motor, and battery. Next is advantage of biohybrid mountain bike compared to normal bicycle. Firstly is quite helpful uphill. Next is high speed, suitable against annoying headwind, helpful for older people and people with health issues, longer distance travel, and lastly less physical effort needed. Problem statement. According to previous study on hybrid electrical bicycle, the decrease of petroleum and increase in greenhouse gas emission are factors that contribute to the development of biohybrid bicycle. In this project, are needed to calculate how much it will be produced the electricity by this mechanism generator. Lastly, to measure how many RPM of crankshaft needed to trigger the generator. For this project, the objectives are to study the electrical powertrain control system for mountain bike MTB. Next, to measure the voltage generated by the generator based on pedaling, and lastly, to review the component used for biohybrid bicycle for better quality. Next chapter is literature review. For the literature review, there are several papers that are close with this project. The first paper has been found out, which is sustainable development using renewable energy technology. So, this paper has been found out that solving the dilemma through the development of renewable energy is a requirement for evolution and precondition for sustainable system. Next paper is design and fabrication of a pedal operated power generator. This paper shows the choosing of DC generator because of the pre-assembled simple and having a lower RPM when it is comparing with the AC alternator that have been best chosen by the lab work to be produce direct current and charging battery without any alteration. Next, hardware design consideration for an electric bicycle using a BLDC motor. This report lists the design criteria for an effective selection of the main component of the electric bicycle, such as the motor selection, battery selection, and controller selection. And lastly is design and development of a hybrid electric two-wheeler. This paper describes the using of regenerative braking mode as charging system of the vehicle. The calculation of the battery capacity requirement was highlighted in this paper. Methodology. Okay. This figure shows the schematic diagram of a biohybrid powertrain for mountain bike. The component 1A is the 52T front sprocket crankshaft. BBM is bottom bracket main. 4B is 16T freewheel. 4A is 24 volt brushless DC motor. 2A is 52T front sprocket crankshaft. BBI is bottom bracket intermediate. 1B is 16T freewheel. 2B is 400 watt turbine generator. 2C is 3-phase voltage bridge rectifier or charge controller. 2C1 is 24 volt digital voltmeter display. 3B1 is 24 volt digital battery monitor. 3B is 24 volt battery lithium battery. And 3A is motor controller with throttle. Okay. Next is design process. A test bench was set up for this project to achieve the objective. Every component required in making the test bench have completely designed using CATIA V5. All the components were arranged on a beam. To be more understanding, I have created a short video to show how this test bench works. Okay, enjoy this video. Okay, let's continue with next slide. The figure above show the assembly component on a test bench. Component will be tested to see if there are any problem and if any adjustment or change are required. Okay. Next is result and discussion. Okay, firstly is structure beam analysis. The beam of test bench was analyzed with material property being steel because it is regularly used in frame and structural construction. The average weight of all components is approximately 115.758 Newton and one mean stress is 771021.063. The formula of factor of safety is ultimate stress over actual stress equal yield stress over maximum one mean stress. The result of factor of safety is 3.24. The beam proved to be considered stronger and safe for this project. Okay, experimental result. The experiment consists of three different speed of pedaling which are low, medium and high. The rotation of crank, voltage generated by generator and RPM of generator were collected in 1 minute. From the graph above, I can conclude that voltage output and number of crank increase as the speed of pedaling also increase. The maximum voltage can be produced at high speed pedaling was 43 volt at 711.9 RPM by turning the pedal with the hand. Last but not least is conclusion. In this study, the development of a biohybrid electrical powertrain was conducted and successfully producing results that can increase the electric range by efficiency and lower energy. It is a combination of human effort with electric power. A test bench is built consists of electrical components such as motor, generator and battery. From the result obtained, the voltage generated by generator is 43 volt at high speed pedaling. It is recommended to use voltage regulator to step down the output voltage that transfer from generator to the battery. At roughly 60 RPM, the battery begin to charge and at 400 RPM, a current about 4 ampere flow into the battery. The result of rotation input in the main sprocket to trigger the generator to produce 24 volt voltage has been achieved. FEA analysis of beam with a 116 Newton distribution load on beam result in a factor of safety of 3. Okay, I think that's all from me. Thank you for listening of my final year project 2 presentation. If you have any question, please do not hesitate, contact me or email me. The details are shown on slide above. Thank you.